by training, work interdisciplinary and interdisciplinary projects with business school as well as engineering school, and I'm housed basically at IIT, Stuart School of Business. I run a clinic, Sustainable Business Innovation Clinic, which our focus in this clinic is to work on a new innovative project to promote sustainability in a wide range of industrial applications. With that, and also my collaborator, Lon, is here. He is a PhD in finance and co-author for this paper, which a part of it we are presenting today. With that, I start to talk about the basic main goals and objectives of this research, where we started and how we started. A statement of the problem. The issue which we are dealing with, nevertheless, how advanced our technologies are, is increased level of CO2 emission, period. That's what we are observing. That is due to economic development activities and also due to not efficiently incorporating technologies or strategies we have put together from technical point of views, policies at some level to address carbon emissions from technologies which are using at wide range of operations. Data has clearly indicated that, as we see. We have tried to reduce our carbon emissions in 4 or 5 years ago, but the last 2 years it has increased. Most of the increase is contributed to kind of China, India, US, of course, and cumulatively other developing nations. We are seeing the effect of climate change, carbon emission, GHG emissions, atmospheric reactions, and basically, I don't think we are having 4 seasons anymore. We have 4 sections of multiple seasons at the same time. These variations are extremely not efficient and proper for economic systems because trees are confused. Farmers cannot do their farming this year, particularly in Midwest, because the soil is full of water, right? It's wet, it's not ready. So having all that said, the question I ask is, are we really making, besides focusing heavily on technological innovation and making it bigger, faster, more efficient, but still carbon emission is high, are we making a structural, economic, and societal shifts needed to combat increase in carbon emissions? So what we are missing, looking into the ideas which are put in front of us, like a design of a smart cities, which we are moving forward to, what do we need to be able to fit into the concept, design, and characteristics of smart cities? So what we have actually as evidence for us, seeing that carbon emissions are increasing and is going to increase even more during the next few years, are the data which suggest basically emissions of carbon and excessive use of demand for energy, particularly electricity, which 30% of energy we use, give or take, is about 29% of total energy which we produce is going through the electricity used by society, which includes industry, businesses, buildings, me and you. So US apparently lead the road, right? Has much higher impact and energy use than anticipated in the world. We also look into the relationship between high-level use of electricity and carbon emissions. Recent data, of course, data changes according to time and our tools and techniques which we use to collect data, analyze data. Big data analytics is a big thing right now in the market. It's showing that it's about 7.7 times minus 4 metric tons of kilowatt hour is of carbon dioxide is emitted per kilowatt hours of electricity use. And in the last slide indicated how much kilowatt hour on average is used per capita. So as per capita, we are contributing heavily to the amount of carbon emissions by the way we live. We use our energy. We utilize every rooms, we utilize our computers, etc., and how we behave as a person. Again, looking into data and plotting the variations which we observe over time, it's clear that we have enough reason to think about maybe the way we are operating is not efficient to managing our carbon emissions. So we have to find a way to maybe engineer society as we're engineering our technologies, trying to see how society is going to contribute to the role in combat against carbon emissions and climate change. Our proposed model. We are addressing climate change 1% at a time. And by that we mean we are looking into a systemic socio, techno, and economic approach. We take all these three parameters into estimation and modeling and strategic design. Society is a big factor in this whole formula to identify how we can reduce our carbon footprint as a nation. So our proposed model basically suggests application of smart technologies. I will briefly explain because time is too short, so I go through it very fast. My apologies in advance. Smart technologies. We have a team at Electrical Engineering, Computer Science Engineering Department at the IIT, which are looking into special sensors, which is used like a credit card scanner, and a building will be equipped with. And also, we are looking into, and I'll explain why that's important to our model. Also, we are looking into decentralization of electricity use and accounting. We know that since 2010, which was a global conference on importance of moving from centralized economy to decentralized economy, and the smart cities are indications of that path of thinking, we are looking into, I say that, okay, if you want to have electricity use, we are going to look at every single person's electricity usage reduction. And for that, we have to have some intense, some benefits, some ways that we can promote that type of behavior on an individual basis. We have to have a reason to perform well, if you may. So, and financing electricity use. So what is the best motivators than if I tell you guys, well, dear Amir, if you reduce your electricity by 1% a month, and we know about it, we can increase your credit score. Would you do it? And credit scores is a basic numbers used in the financial market, right, for everybody. If you want to make a loan, take a loan, you need to have a good credit score. So that is basically our model, very simple. We use common tools, mechanisms which we use in our life, but we organize it in a fashion that we can have it in a smart manner, meaning that we are able to take a real-time data of how we behave with regard to electricity. There are some issues which I talk about, privacy issues, which I have seen before, on monitoring individual or household energy usage. So we talk about that. So we suggest application of smart technologies and decentralization of electricity use and accounting as a major driver for reducing carbon footprint associated with electricity use per capita. We are advocates for developing innovative financial tools. That's what we present today. For building a credit line for electricity users through a decentralized accounting systems. Decentralized. We are not looking at electricity use bills for a house. We are looking at electricity bills for a father, mother, and maybe the kids, right? Again, this is a baby model. Please remember that, right? We are developing it. 5 minutes. Okay, guys. Okay. So with that regard, we advocate for the developing innovation tools and credit line. We are treating electricity as a good or as a product. We recommend this model, carbon footprint, for different aspects of our lives, which is purchasing water. We have water energy nexus. We have waste reduction and processing, and selecting even transportation system, which can use the benefit. So our CO2 reduction model, the basic CO2 reduction model, is based on smart technologies, application of energy use patterns, and looking at the financial models which can be used in collaboration, feeding each other, in order to develop a system which can reduce electricity use. Again, we are developing these new technologies for scanning electricity cards, and we have social engineering program which we are working with Human Sciences Department. We have a partner with that project. And also developing algorithm through which we are estimating credit scores based on energy use data which we collect in real time. Basically, our model, which we are suggesting, is used as follows. Individual apply for a credit card, utilities sponsor the credit card, applications provide information about individual using electricity, and those information are used. Electricity usage, anytime we want to have access to energy use, we scan our card and we buy electricity in real time. It's a hypothetical model, you guys remember, for future. And then, based on this information which we have, through analyzing and processing information for credit cards, we are going to identify and background information which we have for individual, identify credit scores, and behavior on how credit cards are going to be used and electricity use, if we're having reduction over time, etc. We are providing and modeling the process and calculating in scores, credit score for individuals. So our model estimating energy efficiency scores per capita. We develop a model, again, to estimate individual users' green credit scores if they use electricity credit card as a part of their lifestyle, and comparing the results together. The model utilizes parameters such as estimating weight of evidence based on the data which we collect. We have information value for different categories of information we use. We calculate the scores for each individual characteristic which people have, like their salaries, their basic range of salaries for different people, range of their loans, the credit, etc. And total credit scores is calculated. We have used logistical regression modeling with data which we have and simulation which we do to estimate the credit scores. Basically, we are using explanative variable for our model, which is individual background information, which everybody provides when you apply for a credit card information. Financial status, how much loan we have, how much we pay, which basically credit score companies, they all have it. And credit behavior, how we pay our loans. The parameters play a role, and we are able to calculate the probability from data which we have, an algorithm which we're running simultaneously in real life. We are able to calculate credit score for individual people. I go back here on this. As it is indicated, standard credit score calculations, we see that based on the numbers. 1 minute? Yes. Yes, of course. So we are going to analyze the credit scores, and we see that how, based on information on individual person, we can calculate the credit scores. We model this process by incorporating and including energy use behavior information data as well. After calculations are done, we clearly see that the credit scores are increasing for people. If they behave properly with respect to use of their electricity, they reduce it on time, and also they pay their bill on time. They are, without doing anything else, the credit score goes up. People have much higher financial incentive to do this. When we compare the results of standard credit scores and green credit scores, and we saw variations that those people which they pay attention to the level of electricity use in any form and fashion, leaving the lights on or leaving a computer on all the time, etc., they have much better credit score accordingly. We also develop a model estimating electricity usage efficiency, which utilities can use for you. And if you have higher and efficient use of electricity, we did the modeling the same fashion. So you are able to get a better rate with electricity usage because of your better credit and your energy efficiency over time. And it has a financial impacts for individuals. Using this model, our simulation suggests that if every person, we have about 189 million adults in the United States which have at least one credit card. So they know how to use it, they know the rules. If every person reduces their electricity use by 1%, in a month, we estimated we have more than 17 million metric tons of carbon reduction per month can happen in the United States, just 1% at a time. So the benefits, of course, we have social impact benefits, improve education. We have created streams of new jobs. Sustainability is about all of this, and welfare creation as well. And of course, we are anticipating the benefits of our program to be from energy score promoting more energy efficient operation, need new energy policies to support this. We have some barriers, we need the new policies, the security is an issue, and at the end, at the summary, we are able to, a simple, yet a model which is involved with familiar societal financial system rules. We know how credit card works and how your credit score is estimated. And we are proposing a new credit card which controls our electricity use behavior, and that can increase our score. We are looking into enhancing resilience as it is, and we are managing society as a system which needs to be engineered. Thank you very much.
Thank you. Thank you, Nasrin. A lot to share. We've got time for one question.
Oh, sorry, guys.
Does anyone have a question?
Anybody? No?
So this has just been modelled, actually hasn't been implemented yet?
We had done a very simple study on IIT campus, because IIT campus, we have a full smart grid, and we are trying to make the buildings and people also participate as a part. So we did a very simple case study at IIT campus, collected data, used the data in our analysis, but we are expanding this significantly all over the campus with the buildings. The scanners, energy scanners, which are going to be installed in the buildings, are basically almost finished their development. So for the classroom usage, for computer building, lab usage, we all use this scanner, and then we are going to compare the results between prior last year, how it was electricity usage, with this new model, how we can make the impact on demand management. I just mentioned this as well. In 2009, a Nobel Prize winner economist from University of Chicago published two-page paper, said, if every person reduces their carbon footprint annually by 1 ton, we don't need to close our utilities, fossil fuel-burning utilities, because we meet the sustainability objectives. Thank you very much.
Okay, I'm just going to check actually. Is Fernando here? Yeah, perfect. Yes. Okay.
Thank you so much. Thank you. Sorry.